Hello, I am Ramachandra Imman, Assistant Professor in Department of Physics, KTM College of Engineering, Mysore. Now we will discuss how to conduct the experiment single cantilever. The objective of the experiment is determination of Young's modulus of given material, that is scale here, material scale, by single cantilever method. Fine. The formula used in this experiment to calculate Young's modulus is 4mgl cube divided by bh cube delta. Here the quantities are m is mass corresponding to deflection h, it is measured in kg. L is the length of the cantilever used here, b is breadth of the scale, h is thickness of the scale, both are measured in meter, and g is acceleration due to gravity, and as we know the value is 9.8 meter per second square. And here the delta is beam deflection produced for the load m, and again measured in meter. Now let us familiar with the apparatus used here. See, I am showing the single cantilever. Now this material scale is fixed at one end, you can see here. This is fixed with the rigid support here, and which is projected, and we have a free end. This is called single cantilever, is a type of beam. Now we can see the length of the cantilever, it is around 12.4 centimeter where we fix, and we applied the load at the free end here using this tag, and whatever the deflection occurred, that can be seen through this needle. So once we apply the load, the scale is depressed like this, and we release the load. That is stress by strain. So using stress by strain, we can calculate the Young's modulus. And here this is called traveling microscope instrument. This is the traveling microscope I am showing. Since we have variation along a vertical scale, so here we are using the vertical scale. Now this is called a long scale, this is called main scale of traveling microscope, and we can see the small scale, it is vernier scale. The main scale, it is in centimeter, and here actually we have 20 lines in 1 centimeter, so therefore each line carry the value 0.05 centimeter, and we have 50 lines in vernier scale. How to take MSR? To measure MSR, we have to see the 0th line of vernier scale where it is coinciding with main scale, that is our MSR reading. If it is coinciding between two readings, so then least value is our reading. Say if the 0 line is coinciding between 5.45 and 5.5, then 5.45 is our reading. And to read CVD, so among 50 lines here, so one of the line will be best coincide with the MSR lines, and seems to be a single line. We have to read that and record as CVD, coinciding vernier scale division. And by knowing the value of one line in main scale, that is, you can see now showing, yes, in between 2 and 3 you have 20 lines, value of each line is 0.05 centimeter, and here we have 50 lines. In vernier scale. By knowing these two values, so one can calculate the least count of traveling microscope using the formula value of 1 MSD divided by total number of VSD. That will come around 0.001 centimeter. And by taking reading MSR and CVD and by knowing LC, so we can calculate the total reading, that is R equal to MSR plus CVD into LC and measured in centimeter. Now let us come to the focusing part. So we have to focus this telescope, so which is magnified 10 times. So to the tip of the pin used here. This is the tip of the pin we can see here. So to this tip of the pin we have to focus this telescope. Now I am trying to show. So we have focused there. You can see the tip of the pin. It is like this. So we have a cross wire there. Have a look at it. We have a plus mark cross wire. So there the tip of the pin touches the horizontal line. So to focus like this. Then you can take the reading here, that is MSR and CVD. Now here we can see that the zeroth line, it is in between 6.8 and 6.85. You can see that 6.8 and 6.85. Least value is our reading, that is 6.8, because it is in between. Then we have to search the best coincide of CVD lines and MSR line. Set the best line and we record it as CVD. Then, so we applied the load here through this stack. As a result, I can show here, as a result the pin will come down. So whatever the depression in the tip of the pin, that can be directly recorded using this scale.